So in this lesson, we're going to take a look at dividing radicals, which is going to start and probably vary into rationalizing the denominator. Okay, there are two ways we're going to divide radicals. Okay, one of them is if they break down evenly and if they don't. Okay, what we're going to take a look at is if we can divide the numerator by the denominator. Okay, if it's in one radical, you can divide right away, or you can break it up into its pieces. All right. One of the things we're going to have to realize is sometimes it's going to simplify and sometimes it won't. All right. So here's the deal. If you have two radicals and you want to divide, you first divide coefficients or reduce coefficients. After that, you divide radicands, leaving the quotient under the radical, and simplify. Now you can simplify first to do this type of problem, but it's up to you on how you're going to do it. Okay, so let's get started. Let's take a look at this one. See how we can write this as the square root of 80 over 5? Okay, it originally is the square root of 80 over the square root of 5, but we can put it into one radical just like that and actually perform the operation, which is divide by 5, which is just radical 16. And the square root of 16 is 4. If we keep going and take a look at this one, we can just simply write this as the square root of 170 over the square root of 17. As you can see, if we put it as one radical, we can easily divide this, and it's just the square root of 10. Did that break down? No, we're done. Okay. Third one over here, we have now coefficients. 28 divided by 7 can cancel, okay, and it's just 4. Okay, so we have really 4 over 1. Well, now we can put these two together as the square root of 90 over 2, which is the square root of 45. Okay, that's how it's all on the top. It'd be over 1, really, but we don't throw it to 1. And we have a 4 there. Now let's just simplify, which is 9 times 5. Take the square roots of those. Square root of 9 is 3. 4 times 3, radical 5, which is 12 radical 5. All right. Doesn't matter if you put it on cube roots, fourth roots, fifth roots, okay? We'll take a look at the 3 and the 15, or the 6 and the 15. And if you were to reduce this, well, it doesn't go in evenly, but it does take a 3 out of them both, which is going to give you 2 and 5. So we really have a 2/5 on it. Well, now we got to deal with the radical 6, or the cube root of 60 over 10. Well, we can combine that into 60 over 10, which is just 6. It's the cube root of 6. The question is, where does it go? Well, if you look at it, it's just going to go on the top. This is because this 10 is getting in there. 10 is going into the 60. It's going into the top. Okay, so you might see it as 2 the cube root of 6 over 5, or you might see it as 2/5 the cube root of 6, which is both the same thing. Right? Taking a look at some others, like this one right here, you can put the radical together. You get 1/2 because there's a 1 in front of it, and then this is radical 20ab to the 5th over 5ab cubed. Do the division. 20 divided by 5 is 4. A and A cancel each other out. B to the 5th, B to the 3rd. Divide to give you b squared. That's all on the top, and this is the square root. Still got our 1/2. Don't forget about it. Now just simplify. Got the square root of that. Oh, perfect squares both of them. Square root of 4 is 2. Square root of b squared is b. So 2 times b, and we get that 1/2. Our final answer is just b. All right, this one right here, if you need to, you can break this up. Remember, you can break, if the bottom is a singleton, you can divide both of them by that. So it's 2 radical 5 on the top plus 6 radical 15. They're both going to be divided by 2 radical 5. Okay. If you were to combine these into one fraction, remember you have the same denominator, just add the numerators. But what's nice is you can see that this is just 1. These are exactly the same. Here we can divide this, that's 3. So I got my plus, and that's a 3. And then I do radical 15 over 5, which is just radical 3. It's on the top, can't do anything, that's our final answer. Do not add 1 and 3 together, because first of all, they're not like terms, and second, if you were to follow the order of operations, you need to multiply first. So you need to multiply the 3 times radical 3, and if you add them, you break the rules of, well, your order of operations. 2 more here. Now if we decided on this one, we could write it as 2 problems, 375 over radical 3 plus radical 540 over radical 3. And then we just divide those two, and that's 125's radical plus the square root of 180. And then we just reduce, which is 25 times 5, so that's 5 radical 5. That is, now this is a tough one to see. This is 5 times 36. 36 times 5. So you take the square root of both of them, that's 6 radical 5. Add them together. Oh, look, they have same radicals. So, 6 radical 5. You can add just the coefficients, and you get 11 square roots of 5. Last one over here, if you wanted to do this one, let's see if we could do it without it, where both of them get divided by 4 radical 2. 4 goes into 8 twice. 2 goes into 24 12 times. Plus 4 goes into 12 3 times. Radical 2 goes into radical 2 once. This changes to 4 times 3. Take the square root, so that's 2 times 2 radical 3 plus just 3, which is 4 radical 3 plus 3. Okay, so those are your basic division types of problems. Okay, last question I have is about a perimeter of a square. Okay, well, the perimeter of a square is equal to 4 times the side. Well, it tells us that the perimeter is the square root of 112. That equals 4s. So to find one of the lengths of the square, we just got to find s. If we just divide by 4. Well, if I divide by 4, you're going to see that, oh, that doesn't really go in. We need to reduce 112. All right? So if you look at it, it's 16 times 7, actually. And the square root of 16 is 4 times the square root of 7 all over 4. So a side equals the square root of 7. Which leads us to the second part, is what's the area? Well, area of a square is side squared. Well, area equals the square root of 7 squared. Well, that's the square root of 7 times the square root of 7, which is the square root of 49, or just 7. If you take two radicals with the same number and multiply them, you just get rid of the radical. So, let's take a look at rationalizing the denominator. What that means is, if you're going to rationalize the denominator, it's changing the denominator to a rational number, okay? So, there are two ways you can do this. If the denominator is a monomial or a binomial, okay? So, we should know how to rationalize a monomial. Well, we really don't should, okay? I'm going to show you how to do it, all right? So, I'm going to just take a look at the first one here, which is 1 over the square root of 7. I'm going to say to myself, hey, I want to make that bottom, a rational number. Well, I'm going to multiply it by something. I'm going to multiply it by whatever the denominator is, or at least the radical part of the denominator. Okay, radical 7. Well, if I do it to the bottom, okay, if I do it to the bottom, I have to do it to the top. Because you can't just multiply something by radical 7. It's like taking my pay and multiplying it by 10. You just can't do that. It'd be awesome, yeah, but the world doesn't work that way. All right? So, if we do that, what's going to happen is square root of 7 times the square root of 7 is just 7. Now I have a rational number at the bottom. It's okay to have a radical on the top. That's the whole point, is to get rid of it out of the bottom, not the top. Okay? So to rationalize monomials, you're going to multiply the radical denominator by the radical itself. However, we can't just leave the numerator alone. We have to multiply the numerator by the radical part. And then we're multiplying by this, which is just a form of 1. Okay? After that, you reduce, and then you're done. Well, there's two ways to do it. You can multiply the top and the bottom by the denominator and reduce the new radicals you're making. But I'm going to tell you something. You can be multiplying by some pretty big things. So it's usually easier to reduce the denominator and then multiply by the radical portion only. Right? It's also more convenient if you simplify the top too. Okay? This is true for square roots. Cube roots take a little bit more work, and we'll get to those. Okay? So we just did the first one. Let's take a look at the second one. 8 over radical 5. It's already reduced, so we're just going to multiply by radical 5 over radical 5. That's the denominator. That's 8 radical 5 on the top. 5 and 5 give me radical 25, which is just 5. Can't reduce. No radicals in the bottom. Done. Let's take a look at 6 over radical 8. Well, I'm going to reduce radical 8 to 4 times 2, which is 2 radical 2. Now, all I got to do is multiply by the square root of 2 instead of the square root of 8. The top becomes 6 times the square root of 2, all over 2 times 2, which is 4. So 6 radical 2 over 4, and that reduces, so those are coefficients, 3 radical 2 over 2. If I did it at the beginning, just to show you, radical 8, you're going to have 6 radical 8 over 8, and then you're going to have to reduce this to 2 radical 2, which you're going to get 12 radical 2 over 8, which is still the same thing. Just bigger numbers is what happens in the long run there. Okay, let's take a look at this one. If we have things that can divide, you can divide them right away. So I could actually take a look at 8 over 18 and then simplify. What do you get? Well, I can divide them both by 2. It's radical 4 over 9. Look at that. Those are perfect squares, actually. All right, well, let's do that. And square root of 4 is 2. Square root of 9 is 3. It's 3 times 2 over 4 times 3, which then we can cancel those out. It's actually just going to be 1/2 because those cancel out again. If you didn't do that, you could have written this as 9 radical 2, which is 12. You could add 12 radical 2 on the bottom, and then multiplied by radical 2. Then you get 8 times radical 2, which is radical 16. Oh, there's your square root of 4 again. And then your 2's, and you're going to be the same thing. Okay? The last two are a little more work. Let's just take a look at this one right here, because that's easier. Let's just simply multiply by radical 5. We do not have to multiply it by the numerator's work. Okay? Radical 5 times 2. Radical 2 is radical 10. Remember, multiply radicals to radicals. So it's 5 radical 10. The bottom is just 5, actually, and those cancel. The last one we're going to take a look at is when we have the cube root. I have to multiply it by something that will make the bottom a perfect cube now. So some people will say, I'll just multiply by the cube root of 2. Well, that'll be the cube root of 4. We don't know that. What it's telling me is if I've got 1, I need 3 total. So I actually need a second one. So that's not the cube root of 2, but it's the cube root of 2 times 2, which is actually the cube root of 4. Okay? So you are going to multiply by the cube root of 4 on the top and the bottom. All right? The top is 4 times the cube root of 12, all over 3 times the cube root of 8. That we do know. This is 2. So it's 4 times the cube root of 12 over 3 times 2, which is 6. Cancel, cancel. 3 and 2. Okay. The cube root of 12, do we know? No. If it was a square root, we do. Okay. We have to continue rationalizing the denominator, but we're going to do it with binomials next.